Welcome to a slow, beginner-friendly lesson on what JSON is and why it matters, made for absolute beginners. The universal format. Today you meet JSON, the most common way to move structured data between programs. JSON stands for JavaScript Object Notation, but do not let the name fool you. Almost every programming language speaks JSON, including Python. When a website sends data to your phone, when a config file stores your settings, when two services talk, chances are they use JSON. Today you learn what JSON is and why it is everywhere. A shared language. JSON stands for JavaScript Object Notation. It started inside web browsers as a way to describe JavaScript data, but it escaped that world completely. Today JSON is just a text format for structured data. Every language has libraries to read and write it. The format is human readable, you can look at a JSON file and understand it, and also machine readable. That combination is rare and powerful. Small and powerful. Think of JSON as a shared language. Programs written in different languages, running on different machines, can exchange data calmly because they both speak it. It is the universal translator of the modern internet. Programs speak it. Where will you actually meet JSON? Everywhere. When your phone asks a server for the weather, the server answers in JSON. When you save settings in a config file, that file is often JSON. When a mobile app caches data, when a game saves its state, when a NoSQL database stores a record, JSON. Once you recognize the format, you start seeing it in every corner of modern computing. It is everywhere. JSON has a small shape. An object sits inside curly braces and holds key-value pairs, like a Python dictionary. An array sits inside square brackets and holds an ordered list, like a Python list. Values can be strings in double quotes, numbers, booleans, or null. The real power is nesting. An object can hold arrays can hold objects, and you build up deep, structured data. That is the whole shape. Two shapes. Here is a JSON object. It sits inside curly braces. Each key is a string in double quotes, followed by a colon, followed by a value. Name is Ada. Age is 36. Active is true. Keys must use double quotes, single quotes are not allowed in JSON. The values here are a string, a number, and a boolean. This looks almost exactly like a Python dictionary, and that is not a coincidence. Curly braces. Here is a JSON array. It sits inside square brackets, with values separated by commas. Apple, banana, cherry, 3 strings in order. This looks exactly like a Python list. Arrays keep their order, so the first item is always apple, the second is always banana, and so on. You will use arrays whenever you have a collection of similar things, a list of names, a list of tags, a list of records. Square brackets. Here is where JSON gets powerful. An object can hold another object as a value. The key user points to an object with name and roles. Roles is itself an array of strings. Nesting lets you build real data, a user with properties, each property with its own structure. When you fetch data from a web service, it almost always comes nested like this. Reading nested JSON calmly pays off forever. Objects inside objects. JSON bridges worlds. A server in one language, a client in another, a database somewhere else, all connected by a simple shared text format. It carries meaning across every boundary in modern software. It connects worlds. Here is what a real JSON response looks like, say, weather data from a web service. City is a string. Temperature is a number with decimals. Forecast is an array of strings. Source is a nested object with its own keys and values. Mix objects, arrays, and primitive values, and you can describe almost any real-world data. This is what you will parse and navigate every day as a Python developer. Real data looks like this. JSON has only a few value types. Strings in double quotes. Numbers, with no quotes, integers or decimals. Booleans, written lowercase as true or false. Null, also lowercase, meaning nothing. Arrays in square brackets. Objects in curly braces. That is the entire type system. It is small on purpose, so every language can map JSON to its own types without ambiguity. Python maps them cleanly, as you will see next. A small type system. Here is how JSON types line up with Python types. A JSON object becomes a Python dict. A JSON array becomes a Python list. Strings stay strings. Numbers become int or float depending on whether they have a decimal point. JSON true becomes Python true with a capital. JSON null becomes Python none. The mapping is almost one-to-one, which is why working with JSON in Python feels so natural. Almost one-to-one. The mapping between JSON and Python is so clean that you may forget it is happening at all. What looks like an ordinary dict in your code was a JSON object a moment ago, traveling across a network or resting on disk. Clean and natural. Notice the small differences in spelling. In JSON, booleans are lowercase true and false. In Python, they are capitalized true and false. In JSON, nothing is null. In Python, it is none. When Python parses JSON for you, it converts these automatically. You write Python with Python spelling, and the JSON library handles the translation in both directions. You rarely think about it. Spelling differs slightly. Here is the most common JSON mistake: a trailing comma after the last item. In Python, a trailing comma in a list or dict is harmless. In JSON, it is strictly forbidden. The parser stops and reports an error. When a JSON file refuses to load, check for trailing commas first. They are easy to add by accident when you edit a file by hand, and they are easy to fix once you spot them. No trailing commas. Second common mistake: single quotes. In Python, strings can use single or double quotes interchangeably. In JSON, only double quotes are allowed, for strings and for keys. Single quotes cause an immediate parse error. If you build JSON by hand, use double quotes everywhere. Better still, let Python build it for you with the JSON library, which you meet in the next lesson. Double quotes only. Third surprise: JSON has no comments. You cannot write hash comments like in Python, and you cannot write / comments like in JavaScript. JSON is pure data. If you need to document a JSON file, do it outside, in a README, or in a key whose value is a description. Some tools accept comments as an extension, but strict JSON does not. Keep JSON files clean and comment-free. No comments at all. JSON has strict rules. Tiny mistakes, a wrong quote, a stray comma, and a program refuses to read it. The good news: the rules are small and learnable, and soon they feel natural. Small rules, learnable. One important note: JSON is data, not code. A JSON file describes values, but it contains no instructions and cannot run on its own. Parsing JSON is safe by design. Reading it will not execute anything. That said, you should still only open JSON from sources you trust, because the data might be misleading or large. But you never need to worry about a JSON file running commands on your machine. Safe by design. Once you know the rules, you can read JSON by eye. Objects, arrays, values, the structure becomes as familiar as a sentence in your own language. Read it calmly. Here is how to read JSON by eye. First, look at the outer shape. If it starts with a curly brace, it is an object. Look at the keys. If it starts with a square bracket, it is an array. Count the items. Then walk down, pick a key, see what its value is, and if the value is another object or array, repeat. With practice, you will scan JSON as easily as you scan Python. It is just structured text. A skill you build. When will you actually use JSON? Whenever your program talks to something outside itself. Calling a web API to get the weather, JSON comes back. Reading a config file at startup, likely JSON saving user preferences between runs, JSON sending data between services, JSON over the network. Once you can read and write it, a huge category of real-world tasks opens up. Every single day, JSON is a text format for structured data, used everywhere programs exchange information. Two shapes: objects in curly braces and arrays in square brackets. Values are strings, numbers, booleans, or null. Rules are strict: double quotes only, no trailing commas, no comments. The mapping to Python is almost 101, objects to dicts, arrays to lists. Next lesson, you read and write JSON from Python code. Objects and arrays. You now know what JSON is and where you will meet it. The next lesson is pure code. You import Python's JSON module and turn JSON text into dicts and lists, and back again. Once you can do that, you can read any config file, parse any API response, and save structured data to disk. The bridge between JSON and Python is small, calm, and surprisingly pleasant. Code comes next. If you want to lock this in, read this small JSON by eye. What is the type of the price value? It is a number, 12.50. How many items are in tags? 2. School and office. Is in stock true or false? True. If you can answer all three calmly, you can already read JSON. Next lesson, you teach Python to read it for you automatically. Read by eye. Thanks for meeting JSON. Next we read and write it from Python. JSON is everywhere.